Welcome back to the last section of this title, where we're going to be exploring another set of design patterns called behavioral design patterns. In this section, we're going to meet the chain of responsibility design pattern, the observer, and the state design pattern. So let's get started. And let's start with the chain of responsibility. The chain of responsibility design pattern links objects to each other like a chain. There is no central control. Each link decides if it continues to the next chain or not. The ideal scenario for this type of design pattern is really found in animation, where there's a lot of complex animation happening that are related to other objects as one animation spreads over or floods over to the next item and it morphs and changes in the process. Let's start building our first chain of responsibility in this lecture. Chain of responsibility design pattern is so amazing. I'm going to jump right into it because we have a lot of steps to do, and we're going to split this down into 2 lectures just so we don't run a gamut too long. I'm going to go right away to our basic shape, our circle, and I want to add 2 prototype methods. The first one is going to be the next. Now, the next function, more accurately, will accept a shape, which is going to be the next in turn type of shape. Basically, what we're doing now is we're creating a chain. And what I want to do is I'm going to basically check to see if this shape is a shape. Beautiful. Then go ahead and set my next shape to be this shape. And I'm going to go ahead and also return this.next shape. And again, I don't want to get negative reviews for not using open and close brackets. So here we go. Open and close bracket in our if condition. I tend not to. I just like it because it's smaller, but I know a lot of people hate it when I do it. So here we go. I set that in the right way. All we did here is we just created a chain of elements. And I can now connect a lot of circles together, or squares for that matter, because our square is implementing our circle as well. All right, so now that I have the next, what I want to do is one more method, and this next method is going to go ahead and add the actual actionable item, which I'm going to call this chain do. And the chain do is going to do something similar that we've done before, where I'm going to set the function name as a string as the first parameter, and I'm going to send the arguments as an array. And last but not least, I'm going to send the count so we know how much is left to be done. Now that we configure this, let's go ahead and start figuring out the logic here. What I really want to do is I want to create this action sending these arguments. So let's go ahead and do that immediately. Okay, so this action. And what else do we want to do? Once we have access to the action, I want to call the apply. And with the apply, first I want to keep the same scopes, keep the same this. But next after that, I want to send the arguments that we just sent through. All right, so that's it. That we're doing no matter what. Every time chain do is called, we're automatically going to call the first action to be done. The next thing that we want to do is we want to check, do we still have any count left? Now notice where I'm putting the count only after I did the action. So even if there was 0 here, it would still do it once. Now the idea behind this is in programming, a lot of times 0 is 1, like with arrays. 0 has some sort of a value. So if we're sending in 5, we're really creating 6. If we really don't want to do this, then we might want to wrap our condition around all of the item, even before we start the action. In this case, I'm quite happy to say that I'm accepting the fact that 0 is another count. So if I say 5, that means I want 6. And the next thing I want to check to see if the count is there, and also there is a next shape. Because if there is no next shape, it's over. Only if the 2 are in existence, only if there is a count left, which is more than 0, and also there is the next shape, only in that case I'm going to go ahead and call that next shape and literally trigger the same chain event, same chain function, and just go ahead and just send all these parameters exactly the same way, limited to one difference. I'm going to go ahead and subtract the value by 1 by typing there minus before the count. So again, just to get this really clear, anytime I call this, let's say I call this with some sort of action, and let's say I'm calling it 0 time. It's going to commit that action, and then 0 is not true, so this is never going to happen. If the value is 1, then it's going to go ahead, commit the action, check to see is 1 existent? Yes. Do I have a shape set? Yes. And then I'm going to go ahead and continue down the path and call this element sending 0 this time around, next time around, It's not going to perform the if condition. Now, this is very, very similar to a recursion. Now, if you know what a recursion is when a function calls itself. Instead of having a recursion, what we're doing here is a function calling a same exact function in a different object. It's very, very similar to a recursion. In many ways, a recursion is a chain, but not exactly, because it's a chain inside of itself. So maybe it's a loop. Contrary to this is a chain, which it's separated to different pieces. So now that we configured and created the next and the chain do, we really have the core here, the basic functionality here that will enable us to then go into our singleton and operate and create really that chain event. In this lecture, we built the core foundations to enable us to chain and link different objects together. In the next lecture, we'll complete the task of actually chaining items together and creating together a sort of an animation. So join me in the next lecture where we complete the topic of chain of responsibility.